I'm going to give a brief introduction to interfaces in Go. This is not absolutely important for you to understand to follow along in this course overall, but this will make things easier for you when we work with gRPC, because these concepts will come into picture during that time. So to give an overall idea about what interface is that it's a defined behavior. So if any behavior you can define it easily, then that can be considered as an interface. And it's good for code reusability. What I mean by defined behavior is that, for example, if we say a person is wild, then what does it mean? He probably parties hard or goes for adventures or stays up late. So a wild interface may have an adventurous behavior. Similarly, so if anyone implements this adventurous behavior, then that person can be of type wild. Another example can be, let's say, human. A human can speak or write or read or complain. Uh, so a human interface may have a speak behavior. So just to give a physical understanding of what interfaces actually mean. So anyone who implements this speak behavior, then it can be of type human. So I'm going to write some code now to show how interfaces work in Go. So we get rid of this. Okay, so let's say I define an interface type. So type human interface. This is how an interface is defined in Go. So a human can have the ability to speak. So what did I just do? I defined this type and I said anything or any type that implements this speak function can be of an interface human. So let's say I create a type called person, and this is of type struct. So structs are basically short form of structures, and these are a particular type in Go. So under a struct you can have multiple types of variables. So let's say in my case a person struct has a name which is string, and let's say email which is also string. Now this person type can implement this speak functionality to be considered as a human. And how it can do is by defining it in the following way. So we can do something like func then the person speak, and what does it do is it simply prints. Okay, so this looks like a usual function definition except this part where, you know, in parentheses we have this p person. So this basically telling that this is basically telling that this person type has implemented this function, and which is why now it can be the person type is of type human interface. Okay, so if I have, let's say, a function called say something, okay, which has of let's say h human, it takes human as an argument and it just calls speak. So if I define, let's say, a person P here, let's say person which has name, sorry, name, Jack, email, then I can call this function which takes human as a parameter, but because the person type has implemented this speak function, this speak functionality, this is why I can call it directly like this. Okay, and now if I run this, go run.go, it prints, right? So this is roughly an example of how interfaces work. So an interface is defined which has some functionalities, and a type can implement that functionality to be able to consider it as that interface. So another, just to add things up a bit and show a slightly uh, generalized picture here. Let's say if I have this type person now. What if I have a type cat, which let's say also has a name. Okay, and what if that cat also implements this speak functionality? That means it can also be called a human because it will implement speak functionality. So do the same way, see cat speak function, and let's say it just does it just prints meow. Okay, so now if I have a variable, a cat variable, which let's say I define it, let's say it doesn't have a name, I just define it like that and say something C. Okay, so say something takes human as an interface, and because a human interface as a parameter, and because this cat type has implemented this speak functionality, this is why I can call this say something function like this. So if I run it again, see meow as expected. So maybe I can, instead of using this human interface, instead of calling this interface human, I can call it speaker, for example. Which makes more sense now, because a speaker is somebody who can speak, right? So a person can implement this and can speak, and a cat can implement this and speak something. So one real life scenario would be, let's say, okay, if some programmer is working on this, doing something with this person type, and somebody else is working with this cat type, and these types can be different, like here we have name and email, here we just have name, or there can be many other functionalities of a cat, but I can say that, okay, do whatever you want with your types, but ensure you satisfy this functionality. So this is your defined behavior. So as long as they implement this behavior. Yeah, they can be whatever they want, but I can anytime just call, say something, and give uh, that particular variable as a parameter, and it will ensure it speaks. So this is an overall very brief introduction on what interface is and how it sort of works in Go, and which should be helpful in understanding uh, some gRPC concepts in future.